So today I'll be discussing the problems based on two chapters, locus and transformation of axis. So 8 marks from locus and 8 marks from transformation of axis is how it is distributed, right? That is two 4 marks questions in each of these chapters, right? I'll be discussing all those problems. So quite easy to gain these marks because there are only around 8 to 9 questions in locus, which will give you 8 marks, and around 7 questions in transformation of axis that will also give you 8 marks. So that's making these two chapters very simple. In fact, the solutions are also more or less the same for all these questions. Okay, so let us start with those problems. I've already compiled the questions. So let's start discussing the solutions. I want you to concentrate. Right. So here I'll be giving you all the steps that will be involved as well, particularly for IP, so that it will be easier for you to score marks. All right, just give me a second. Yeah. Okay. Yes, Sharat, you're right. This is the latest blueprint. Two questions on locus. That's the latest blueprint. Right. Previously, there's only one 4 marks question for locus. Right now, it's 2 questions on locus. All right. So let's start with the problems on locus, and if time permits, I'll move on to transformation of axis as well. Shall we go on? All of you ready? Right. So the question asks you for a locus of a point. The difference of whose distances from a point minus 5 comma 0 and 5 comma 0 is 8. Okay. So the steps involved, all of you carefully understand the steps that are involved. So let the point, right, be P of h comma k. So in coordinate geometry, like I told you, a variable point or a moving point is always taken as h comma k, and let P be that point. Is that clear? So there are certain points that are given in the question. Let us name them as let A be minus 5 comma 0 and B be 5 comma 0. Right? I've just named the 2 points that are given here. Are we clear so far? Okay. All of you? Now, there will be a mathematical condition in each of these problems. So let's identify what is the mathematical condition. Right? What is the mathematical condition? The difference of whose distances from this point and this point. So the distance PA and the distance PB, the difference is given to be equal to 8. Right? The difference is given to be equal to 8. Is it clear? All of you? That's the mathematical condition that is given. Okay, so I have the coordinates of P, A as well as B. And by using distance formula, I can write PA as root over h plus 5 whole square plus k minus 0 whole square, which is of course nothing but h plus 5 whole square plus k square. Right? That's PA. Similarly, PB is nothing but root over h minus 5 whole square plus k square. Right? In fact, plus k minus 0 whole square, which I'll write it as root over h minus 5 whole square plus k square. Okay, and the RHS is already given to be equal to 8. All right. So a simple idea here is that in order to solve these problems, I want you to use this simple idea. Okay, instead of writing it like this, because there are square roots involved, what I suggest is send one of the terms to the RHS. Right? So PA will become 8 plus PB. If I send one of the terms to the RHS, right? PA should be equal to 8 plus PB. And then I will replace all these terms, because if I square it up here on both sides, right, it will be further more complicated. All right. So that's the reason I don't suggest you to square it up here on both sides. But after doing this step, I want you to square it up. Right? You may try by squaring up on both sides here itself. You will understand why it is getting complicated, as to why I've taken this other approach where I've sent PB on the other side and then square it up. All right. So that will give me PA whole square. I'm basically squaring on both sides. You might want to write it down right? Squaring on both sides, which will give me PA whole square should be equal to 8 square plus PB square plus 2AB term, that is 2 into 8 into PB. Okay, that will give you PA square, which is nothing but square of this, which is H plus 5 whole square plus K square is equal to 8 square, that's 64, plus PB square, that is H minus 5 whole square plus K square plus 16 times root over H minus 5 whole square plus K square. Just have a look at it. Tell me if everything's okay. Right? All of you? Any doubts, anyone? Then you can just proceed by doing simple calculations over here. So K square is a term that will get cancelled on both sides, and when you expand it, right, you'll be having H square plus 25 plus 10H. Just because it is an IP question, right? I'm writing down so many steps, but when you're solving problems for JE, you'll have to avoid these steps. But in case of IP, I encourage you to write as many steps as possible so that you're making the solution clear for the person who's reading your answer. You're making it clear. Okay, 64 plus H square minus 10H plus 25. Okay, plus 16 times root over H minus 5 whole square plus K square. Is it clear, all of you? Any doubts? Right? So H square and 25 also get cancelled. Left with the remaining terms, which I am going to send on the LHS. I'll only leave this term on the RHS, everything else I'll send it on the LHS. That will give me 20H minus 64. Okay, this 10H adds to this, and that will become 20H minus 64 is equal to 16 root over H minus 5 whole square plus K square. That's K square. All right. And from these two, I can take out a 4 common and strike it off, which will give me 5H minus 16 is equal to 4 times root over H minus 5 whole square plus K square. Fine? All of you? Now I'll square it up again for the second time. Though it's getting a little cumbersome, right? It's far easier, much more easier when compared to what you do if you square up on both sides in the original equation itself. So I would still recommend you to do it this way itself. Squaring on both sides again, right? Squaring on both sides. What does that give you? Just a second, right? That will give you, let me do it over here. Continuation of this. Okay. Squaring on both sides will give me 5H minus 16 whole square is equal to 16 times H minus 5 whole square plus K square. Okay, now the rest is simple. So it will give you 25H square plus 256, right? Minus 160H is equal to 16 times of H square minus, in fact, plus 25 minus 10H plus K square. Rearrange all the terms. For that, let me just expand it a little bit further. Plus 256 minus 160H is equal to 16H square plus 400 minus 160H, okay, plus 16K square. So 160H gets cancelled, and the leftover terms are 16H square. So everything I'm bringing it onto the RHS, that's 16H square, okay, 16K square. In fact, everything I'll bring it onto the LHS, that will be relatively easier. 25H square minus 16H square will be 9H square minus 16K square is equal to 400 minus 256, that is 144. Okay, you can leave the answer over here, but mind you, you'll have to generalize it. As you remember, generalizing it for x comma y. So all you need to do is to replace h by x and k by y. So that will give you 9x square minus 16y square is equal to 144. Okay, that's your final answer. Or you can divide by 144 on both sides and write it as x square by 16, okay, minus y square by 9 is equal to 1. That's another way to write down the same answer. Is that clear, all of you? Yes? Think you have the solution already? Okay. So that's your next question. Just have a look at this question. It's more or less similar, right? Just that there's a modulus involved, which we can handle easily. Okay. No, I wouldn't suggest that. Start with h comma k. Okay, start with h comma k and then generalize into x comma y, because that's the idea of locus. You're starting with a moving point and then generalizing it. That's the whole idea. You understand, all of you? So moving on to the next one. That's giving you PA minus PB is equal to plus or minus 4. Did you understand why I got this? That's because I have removed the modulus over here, okay, and made it into a plus or minus. That will also take the same idea as that we've used for the previous problem. So what you can do is, this is the mathematical condition that you have, which I'll hold it. So let the point be P of h comma k. Standard question, standard steps. Okay, let point be P of h comma k. And what is the mathematical condition? The mathematical condition is that, am I audible, guys, all of you? The mathematical condition would be that, just a second, yeah, right, is PA minus PB inside modulus is given to be equal to 4. Okay, which I am converting it into plus or minus and writing it as PA minus PB. The modulus I am removing it and writing it as PA minus PB is equal to plus or minus 4. So same steps. PA is basically equal to the distance between P, which is h comma k, and 4 comma 0, right? So that's the root over h. Let me just check. Yeah, A is P, A is 4 comma 0, so h minus 4 whole square. Sorry for that, h minus 4 whole square plus k square, which is of course equal to, let me leave it like this. So PB will be equal to root over h plus 4 whole square plus k square, right? And then I have PA minus PB is equal to plus or minus 4. Like I said previously, the best way to solve it is by taking one of these terms to the RHS and writing it as plus or minus 4 plus PB. Is it clear? Right? So this plus or minus 4 prevails till the end. Let's see when it is going to get eliminated. Okay, so just to be clear, I'll square on both sides. Okay, I'm squaring up on both sides, which will give me PA square is equal to A square plus B square plus 2AB. So what is A square here? It's plus or minus 4 whole square, which is 16. Okay, it doesn't matter whether you have a plus here or a minus here. In both cases, if you square up, you will be getting 16 only. Any doubts here? All of you? Right? Then plus B square, that is PB square. Again, plus or minus 8 into PB. How many of you have understood this? How many of you have understood this point? Yes, it's because there is a plus or minus here. Okay, had it been a plus, this would have been a plus. Had it been a minus, this would also be a minus. Okay, అందుకే here, since it was a plus or minus, even here I've put up a plus or minus. Right? Now, PA square is nothing but the square of this, which is h minus 4 whole square plus k square is equal to 16 plus PB square, which is h plus 4 whole square plus k square plus or minus 8 times root over h plus 4 whole square plus k square. Right? So k square gets eliminated and the leftover terms are h square minus 8h plus 16 is equal to 16 plus h square plus 8h plus 16 plus or minus 8 root over h plus 4 whole square plus k square. Got it? All of you? So two other terms will get cancelled, h square and 16 on both the sides. Okay. Then all the leftover terms, I'll bring it on to the LHS, which will give me minus 8h, and this comes here as minus 8h, that's minus 16h, and this minus 16 also comes here. So minus 16h minus 16 is equal to plus or minus 8 root over h plus 4 whole square plus k square. So what can I cancel here? Can you tell me? Everyone? Very good. Everyone be active. Keep responding, all of you. More answers. More answers. I want everybody to respond. Yes, check your answer. Yes, you're right. All the others. Wonderful. Wonderful. Right? So I can strike off 8. In fact, I'll write this as minus 8 times of 2h plus 2 is equal to plus or minus 8 root over h plus 4 whole square plus k square. Right? This 8 gets cancelled and I'm left with minus of 2h plus 2 is equal to plus or minus h plus 4 whole square plus k square. See, the only difference between this problem and the previous one is that plus or minus. And of course, those numbers. The numbers are a little different, but the idea is just the same. So what should I be doing? Square on both sides again. Okay, that's going to give me, right? Just a second. It's going to give me 2h plus 2 whole square with a minus, doesn't matter. That's 4h square plus 4 plus 8h is equal to, now when you square it up, this plus or minus gets eliminated. It just doesn't matter whether you have a plus or minus here or not. So it's simply h plus 4 whole square plus k square. Right? So when I expand it, it's 4h square plus 4 plus 8h is equal to h square plus 8h plus 16 plus k square. All right? So 8h again gets cancelled. Right? Any doubts still here, anyone? All of you? So that will give me 3h square, okay, minus k square is equal to 12. All right. So next step is to generalize to x comma y. All right. Next step is generalizing x comma y, which will give me 3x square minus y square is equal to 12, which is your final answer. Clear? All of you? Any doubts, anyone? Yeah, I'll put up the recording as well, either on Drive or on YouTube. You can just have a look at the solutions. Isn't this problem just the same? PA plus PB. So I'll give you 3 to 4 minutes. Are you confident of doing it? Those who are confident, raise your hands of solving this problem right now. Right now, not later on. Are you confident of solving this problem? Raj is Vinay Raj. Okay. Yes, how many of you are confident? Others can still see around 30 of you who did not raise hands. Yes. Finish it off. I'll give you exactly 3 to 4 minutes to finish it. Try doing it, all of you. Yes, so that's your next problem. Find the equation of locus of P if the line segment joining 2, 3 and minus 1, 5 subtends a right angle at P. Okay, so there are a lot of ways to solve this problem. You can use the idea of slopes, or you can simply apply Pythagoras theorem to solve this particular problem, right? So let me just show you as to how the figure is going to look, right? There's one point that's given as 2 comma 3. There's another point given as minus 1 comma 5. Now these two should subtend a right angle at P, which I'm about to call it as h comma k. Is that clear? So when they subtend a right angle at P, right, this should be 90 degrees. A couple of ways that I can give you to solve this problem. The first method being the slopes method. Okay, let's call this point as A and this point as B. Okay, so let's do some assumptions. Let P of h comma k be the moving point. Okay, let A be represented by 2 comma 3 and B be represented by minus 1 comma 5. Okay, so can I just say the first method is that the slope of PA into the slope of PB. Can you tell me what is this product equal to? All of you. Can you tell me what is this product equal to? Wonderful. Everyone. Everybody. Yes. Slope of PA into slope of PB should be equal to minus 1. That can be your mathematical condition. Agreed or not? All of you? Yeah. So your mathematical condition could be, so like I said, for every problem, there is a mathematical condition, which in this case could be slope of PA into slope of PB is equal to minus 1, right? So what is the slope of PA? It is y2 minus y1 by x2 minus x1. Similarly, slope of PB is also y2 minus y1 by x2 minus x1. Okay, so let's do that. Slope of PA, right? Slope of PA should be equal to k minus 3 by h minus 2. That's slope of PA. And what about slope of PB? Slope of PB will be, should be equal to k minus 5 by h plus 1. Okay, and their product should be equal to minus 1. So k minus 3 into k minus 5 divided by h minus 2 into h plus 1 should be equal to minus 1. Going ahead with the calculations, sorry for that. Yeah. So when I expand it, I'll be getting k square minus 3k minus 5k plus 15 is equal to minus of h square minus 2h plus h minus 2. Okay, right? Which will give me k square minus 3k minus 5k is 8k minus, in fact, plus 15 should be minus h square, and minus 2h plus h will be minus h with a minus sign will be plus h plus 2. Right? Simplifying it further, I'd be getting h square plus k square. Basically, I'm bringing all the terms onto one side. Minus h minus 8k plus 13 should be equal to 0, which is before generalizing, and then I'll generalize for x and y, which will give me x square plus y square minus x minus 8y plus 13 equal to 0. Okay, that's the locus of this particular point. Of course, with a given condition. That's one way to do it, by using slopes. Let me give you an alternate method also, right? I won't be using slopes here. Mathematical condition. Again, it's a different method. Okay, you don't have to write both of these. You can just end up writing one among these two. What is the mathematical condition according to Pythagoras theorem? PA square, right, plus PB square, right, this square plus this square should be equal to AB square using pure distances. Okay, so since there are squares to each of these terms, it will be relatively easier. Let's see which one among these is easier to solve. Okay, so PA square, we already know PA, that is h minus 2 whole square plus k minus 3 whole square under root, that's PA. Okay, just a second, that's PA whole square plus, what is PB square? It is h minus, in fact, h plus 1 whole square plus k minus 5 whole square under root whole square. Okay, PA square plus PB square should be equal to AB square. You know the values of the coordinates of A and B. That will give you 2 plus 1 whole square plus 3 minus 5 whole square under root whole square. Okay. So this under root and sorry, got disconnected. Am I audible to everybody? Cool. Okay. So PA square plus PB square. This is what I have written. And then of course square root and square will get eliminated. So that will give you h square minus 4h plus 4. Just be very careful while you're writing the steps. K square minus 6k plus 9 plus similarly h square plus 2h plus 1 plus k square minus 10k plus 25 is the LHS should be equal to right root over 3 square plus 2 square whole square. So you don't have to put the square root. Okay, so that will be 3 square plus 2 square because that's equal to 13. Clear, everyone? Any doubts? Anybody? So just add up all the like terms. H square plus h square will give you 2h square plus k square plus k square will give you 2k square. Okay, 4h and then 2h will give you minus 2h. Then minus 6k minus 10k will give you minus 16k. All right. Plus 9 and 4, which is 13, which will get cancelled with this 9 and 4, and you are simply left with plus 25 plus 1, that's 26, which is equal to 0. Because all terms are even numbers, I can remove a 2 common and strike it off. That's giving you h square plus k square minus h minus 8k plus 13 is equal to 0. And then, of course, you'll do the same steps, which is generalizing for x and y. You can proceed from here. So just generalizing it for x and y. Clearly getting the same answer. Did you understand? So you may decide which of these two methods is easier for you. Do you want to use Pythagoras theorem or would you like to go ahead with slopes? Is this clear, everyone? So it's a little different problem from the previous ones, right? So I've taken P as h comma k as usual, and then I've named the given points as A and B. Okay, the ratio of distance from P to so and so and so and so, basically PA to PB is given to be equal to 2:3. So what is my next step? I need to be writing the mathematical condition, right? What is the mathematical condition? PA is to PB should be equal to 2:3. In other words, PA by PB should be equal to 2/3. You must have identified already that it's relatively much easier if I have squares for the distances, isn't it? Because there's a square root involved in the distance formula. Had it been squares, it would be relatively much easier. So I'll write it like this. Any doubts here? Anyone? Basically writing it as PA square by PB square should be equal to 4 by 9. Okay. And what is PA square? I have the coordinates of P, which are h comma k, and A, which are 5 comma minus 4. So PA square will be nothing but h minus 5 whole square plus k minus 4 whole square. That's PA square. There's a square root and square which got eliminated. And then of course PB square, which is h minus 7 whole square plus k minus 6 whole square should be equal to 4 by 9. Okay. So the rest is pure simplification. Should give me h square minus 10h plus 25 plus k square minus 8k plus 16 is equal to, in fact, divided by h square minus 14h plus 49 plus k square minus 12h plus 36 is equal to 4 by 9. Do the calculations carefully. Just cross multiplying it will give you 9h square minus, right, 90h plus 225 plus 9k square plus 72k, in fact minus 72k, right, plus 16 nines 144 is the LHS, should be equal to, what's the RHS? It's 4h square minus 14 fours 56h, 49 fours is plus 196 plus 4k square minus 48k, all right, plus 36 fours is 144. I'm sorry, this is 72k. Yeah. Any doubts, anyone? I am so sorry. This is, yeah, you're right, Anushri. It's minus 4, gada. So this has to be plus 4, making this plus 8k and then making this plus 72k. Okay, let's make that correction. So going further, 144 gets cancelled on both the sides. And of course, you'll have to bring all the terms onto one side. So 9h square and 4h square, which is 5h square. 9k square and 4k square, which is 5k square. Okay, minus 90h, and this goes on to the LHS, which will become plus 56h. Okay, that's plus, in fact, minus 34. Correct me if I'm going wrong. All okay? Yeah, 34h. Okay, then what about the k terms? Plus 72k, and then minus comes here as plus 48k, which is nothing but 120k, right? Plus 225 minus 196. 225 is here, 196 goes here, that will give you plus 29 is equal to 0, which is your final locus. Okay. Any doubts, anyone? All of you clear? Simple problem, not too many steps here. So this, all these steps will carry exactly 4 marks. Sorry. Okay, so that's your next problem based on a formula on the area of triangle. Similar steps, let P of H comma K be the moving point. Okay, and what is the mathematical condition? The area of triangle PAB is 9 units, so 9 square units. So A is already given, B is also given. Area of triangle PAB should be 9 square units. So let me write down the mathematical condition. Okay, so all of you remember what is the area of a triangle? If the points are x1 comma y1, x2 comma y2 and x3 comma y3, then area of triangle, which I'll denote by delta, is half into determinant of, right, 1 1 1 in the first column, x1 y1, x2 y2 and then x3 y3. Mind you, there is a modulus throughout, and the area cannot be negative, so I'm putting a modulus sign just to make this value positive. Is it clear, all of you? So that's the actual formula for the area of triangle. But here, of course, I have points. You don't really have to write down all these things. You can just write down the area directly. Okay. So yeah, mathematical condition being delta, which is the area, which is half into delta of 1 1 1, right? HK 5 3 and 3 minus 2 given to be equal to 9. Okay, mind you, there is a modulus inherently written. That's a very, very important point. If you forget about the modulus, you will lose 1 or 2 marks. Okay, so only when you have a modulus, you will be getting a plus or minus over here. So what happens is half into det of, in fact, this half also I can send it on the other side. So that's, sorry, det of 1 1 1 HK 5 3 3 minus 2 is equal to plus or minus 18. Did you understand why I have come up with a plus or minus? Because there is actually a modulus here which I did not write, right? That modulus is converting itself into plus or minus, and of course 2 got cross multiplied. Okay, the rest is just expanding the determinant. You may want to do it using the properties, or you can also directly expand it. So 1 times minus 10 minus 9 minus h times minus 2 minus 3 plus k times 3 minus 5 is equal to plus or minus 18. I'm assuming that you would not need an explanation as to how to expand a determinant. Can I? All of you are clear with expansion of determinants of a 3 cross 3 simple determinant? Because you can use properties also. It's up to you whether you want to expand it or apply the properties of determinants, making it minus 19 plus 5h minus 2k is equal to plus or minus 18. Okay, so there are two ways to proceed from here. You can either directly square it up on both sides, which of course will make it a little complicated because numbers are quite big. Okay, or there's another way to solve it. So this basically takes you to two roots. First root is that this is plus, and the second root is that this is minus. So that will make it minus 19 plus 5h. Okay, minus 19 plus 5h minus 2k is equal to 18, or minus 19 plus 5h minus 2k is equal to minus 18. So let's proceed in both the ways. So 5h minus 2k minus 37 is equal to 0, or 5h minus 2k 5h minus 2k minus 1 is equal to 0. Okay, so either this is 0 or this is 0. Can I just write both of these into a single statement as 5h minus 2k minus 37 into 5h minus 2k minus 1 is equal to 0. I'm taking a product so that either this is 0 or this is 0. Okay, Nagada? All of you? Yes? So generalizing for x comma y, you can just write it as 5x minus 2y minus 37 into 5x minus 2y minus 1 is equal to 0. If you have enough time, you may want to expand this and write a second degree equation. Is it clear? But be very, very careful. The problem is actually simple. The complication is happening because of the modulus, which a lot of students tend to forget. Okay, the high scope of losing 2 marks here just because you forget to write plus or minus. Right, a lot of students do that mistake. It's a very common mistake that's made. They forget to write plus or minus, just take plus. It's actually not correct. You need to take both plus or minus. If you take only plus, you will end up getting a linear equation, but it's actually not. It is not a linear equation. You should be getting a second degree equation, mind you. Are we clear with this? All of you. Are we clear? Yes or no? Can I assume, can I expect that you will be taking a modulus and also not forget this plus or minus? Can I expect that? Yeah. So it's a very easy way to trick you by giving this problem, because like I said, most students forget taking plus or minus here. Very good. Right, Amog, you're right. Okay. Similar problem based on areas. Can you finish it by taking plus or minus? Can you do it? We'll give you 3 to 4 minutes time. Can you, all of you? Excellent. Start doing it. Similar idea. Yeah. Last problem. Already given in the form of squares, so that makes it relatively quite simple when compared to the previous problems. Have a look at it. So let P of h comma k be the moving point. Okay. So PA square, in fact, put the mathematical condition, right? PA square plus PB square should be equal to 2 times PC square. All right. What is PA square? You have P and then A. Square of the distance is nothing but h minus 1 whole square plus k minus 2 whole square. Okay. PA square, that is, plus PB square is h minus 2 whole square plus k plus 3 whole square is equal to twice of PC square. So what is PC square? It's h plus 2 whole square plus k minus 3 whole square, right? Just expand it. So h square minus 2h plus 1 plus k square minus 4k plus 4, the first set of terms, and then h square minus 4h plus 4 plus k square plus 6k plus 9 is equal to 2 times of h square plus 4h plus 4, right, plus k square minus 6k plus 9. Is it clear? I'll just rewrite this RHS by multiplying it by 2. So that's 2h square plus 8h plus 8 plus 2k square minus 12k plus 18. Okay. So now a lot of things are going to get cancelled. So h square plus h square, which is 2h square, gets cancelled with 2h square. Similarly, k square plus k square, that's 2k square, which got cancelled. Okay. What are you left with? The remaining terms, that is minus 2h, okay, minus 4h, and then minus 8h, which is nothing but minus 14h. All the h terms, I brought it on one side. We give you minus 14h. Similarly, minus 4k plus 6k plus 12k. Okay, minus 4k plus 6k plus 12k, which is plus 14k. Okay, and then the constant terms, that is 1, 4, 4 and 9, that is 18. Okay, and this is 18 plus 8, that is 28. So that's plus 8 is equal to 0. Correct me if I'm wrong, because I can take out 2 common and then also multiply it with a minus sign. That's 7h minus 7k minus 8 equal to 0. Generalizing for x comma y, 7x minus 7y minus 8 should be equal to 0. Right? Where did I go wrong? Yeah. 4 gets cancelled. Yes. Give me a second. Plus 8. Oh, but I multiplied it with a minus sign. So give me. Yeah, you're right. This is minus 8. That will be plus 8, and that will be 4. You're right. Yeah. So that's minus 8 because I multiplied with minus sign, it will become plus. And then since I've divided by 2, it will be plus 4. I've divided it by 2 also. So that will be plus 4. Okay. All of you understood? So these are the problems that I want you to practice on Locus. Like I said, a definite 8 marks if you're confident about these problems. Okay. So we've done solving problems on Locus, which consists of 8 marks weightage. And then the next is transformation of axis. Again, 2 4 marks questions, 2 short answer questions, and that will also consist of 8 marks. Okay. So having solved these 2 chapters, you will be confidently gaining 16 marks. Okay. So that's the importance of these chapters. Right. So let's start. So first question. When the origin is shifted to minus 1 comma 2 by the translation of axis, find the transformed equation of so and so, right? So you need to understand that this is the original equation. The challenge lies in identifying what is the original equation and what is a transformed equation. Okay, how do you identify that? By looking at the question, right? By the words that are given in the question, you can understand that when the origin is shifted, there is a small spelling mistake. When the origin is shifted to so and so by translation of axis, find the transformed equation of this particular thing, which means this is not yet transformed. Okay, it is supposed to be transformed now, which means this is the original equation. All right, there are a couple of formulae that governs the entire idea of shifting of origin, right? That is small x is equal to capital X plus h. In fact, capital X is equal to small x plus h and capital Y is equal to small y plus k. Okay, these are the 2 formulae that I want you to remember very simple ones, based on which, yeah, your entire transformation of axis, particularly shifting of axis, is based upon. Is it clear, all of you? So shall we proceed? Yeah, all of you. Let's take, I think in the first time when I've explained, I've given you different notions. So let me use the same notion here as well. Basically, small x, I will take it to be the old coordinate, and capital X, I'll take it to be the new coordinates. Is that clear? So it's actually small x is equal to capital X plus h. It's up to you how you want to take it. Small y is equal to capital Y plus k. The previous one was also correct. It's just that your notations should be clear. All right. Small x should be equal to capital X plus h, and small y should be equal to capital Y plus k. So this being the original equation, I'll give you how to write down the steps. Right. So solution. The original equation is given by, right, x square plus y square plus 2x minus 4y plus 1 is equal to 0. That's your original equation. Okay. The origin is shifted to h comma k, which is basically already given by 1 minus 1 comma 2. Is it fine, everyone? Right. Now, this being h and this being k, can I write x as capital X minus 1 and y as, in fact, small y as capital Y plus 2. Okay. So these are the values that I'm going to replace in the original equation to get your new equation. Quite a simple problem, right? So small x is nothing but capital X minus 1 whole square plus capital Y plus 2 whole square plus 2 into capital X minus 1 minus 4 into capital Y plus 2, okay, plus 1 is equal to 0, is what you'll be getting. Okay, so when you actually expand it, x square minus 2x plus 1 plus y square plus 4x plus, in fact, 4y plus 4 plus 2x minus 2 minus 4y minus 8 plus 1 is equal to 0, right? 2x term gets cancelled, 4y also gets cancelled, and you're left with x square plus y square. Observe the constant terms, plus 1, which is plus 2, gets cancelled with minus 2, okay? And then plus 4 minus 8 will be minus 4 is equal to 0. Or of course, you can also write it as x square plus y square is equal to 4, which is your final equation, also called as the transformed equation. Any doubts, anyone? Quite a simple problem to gain 4 marks easily. All you need to do is to be careful with the calculations. Keep responding, everybody. I'm only getting around 25-30 responses. All the others also need to respond. Are we clear? Very good. Yes? Good. Right? Let's move on to the next problem. So clearly given, when the origin is shifted to so and so, the transformed equation of the curve, right? So it is already mentioned that this is the transformed equation. Clearly mentioned in the question, right? All of you? Not required, not required to draw anything. You can just directly solve equations. That's it. Figures are not required here. Okay, this is a transformed equation. So let's go ahead with the solution. So the transformed equation is, so since it is the transformed equation, right, we know that this is the equation in the new system, not in the old system. So though in the question it is given in terms of small x and small y, right, I want you to visualize in terms of capital X and capital Y, because it is already mentioned that it is a transformed equation. Did you get the point, all of you? So instead of writing it this way, I will write the same equation but using capital X and capital Y. 3 capital X capital Y minus 2 capital Y square plus 17 capital X minus 17 capital Y minus 11 is equal to 0. Because they've already told you that this is a transformed equation. See, mind you, they will be using, just a second. Yeah. They will be using small letters only, right? So, but you need to be very clear about the transformed equation, which is actually the capital letters. Is it clear? All of you? Any doubts still here? Anyone? Yeah? No. Let's proceed further. So we already know from the previous question itself. So each time I want you to write this particular formula in terms of small x and small y, which is converting it into capital X and capital Y. So small x is basically equal to capital X plus h, which gives me capital X is equal to small x minus h. Similarly, small y is equal to capital Y plus k, which converts itself into capital Y is equal to small y minus k. So in this problem, this is what we are going to use, right? So what does that give me? In fact, the origin is shifted to, yeah. So let's check the point to which the origin is shifted. It's 2, 3. The origin is shifted to 2, 3, which we denote usually by h, k. Okay, it's denoted by h, k. Fine. So capital X will actually be nothing but x minus 2 and capital Y will be nothing but small y minus 3. So using these two, I'll convert the equation, right? The new equation is, the old equation or the original equation is, right, x minus 2 whole square plus 3 into x minus 2 into y minus 3 minus 2 into y minus 3 whole square plus 17 into x minus 2 minus 17 into y minus 3 minus 11 is equal to 0. Okay, simplifying this further, the rest is your algebra. You'll be getting x square minus 4x plus 4 plus 3 into xy minus 3x minus 2y plus 6 minus 2 into, right, y square minus 6y plus 9 plus 17x minus 34 minus 17y plus 51 minus 11 is equal to 0. Okay. Any doubts still here? Anyone? So just simple algebra. So that will give you x square minus 4x plus 4 as it is plus 3xy minus 9x minus 6y plus 6. Correct me if I'm going wrong. Minus 2y square plus 12y minus 18. Okay, plus 17x minus 34 minus 17y plus 51 minus 11 is equal to 0. So let's check all the x square terms. So there's one x square term. Let me write it as x square. Then minus 2y square. You know the natural order in which you should write the terms, right? It's easier to remember and it's, more appropriate if you use the natural order. All right. So that will give you x square minus 2y square. Let's check the xy terms, right? What is it? What are the xy terms? Yeah, this is 18. I'm sorry. Right. Just a second. That's 18. It's 3 times 6 is 18. Right. So x square minus y square plus 3xy. Let's check all the x terms here. So minus 4x minus 9x plus 17x. Right? Minus 4x minus 9x plus 17x, which is nothing but plus 4x. Okay, and let's check the y terms here. Minus 6y plus 12y and then minus 17y, which is nothing but minus 11y. Okay, the 3 terms for this. And then let's check all the constant terms. So that is 4 plus 18, that's 22, minus 18, that's 4 again, right? Minus 34, that's minus 30 plus 40. So that is plus 10 is equal to 0. Okay. Readouts, anyone? All of you? Right? Shall we proceed to the next problem? So let's move on to the next problem, which is based on rotation of axis. Okay, just have a look at the question. Keep in mind that these are very, very simple chapters, both locus as well as transformation of axis. I want you to be thoroughly solving these problems. Okay, so particularly for rotation of axis, we've discussed a table that is involving small x, small y, and then capital X, capital Y, right? So this will be cos theta, sin theta, minus sin theta, and then cos theta. We've derived this table also. So as of now, it's not the time for derivation. So I want you to remember this table each time when you're solving this problem based on rotation. Okay, so small x, small y here. Basically, what this means is small x is nothing but, so if you want to write down the value of small x, you go in this way. So that is capital X cos theta minus capital Y sin theta. Similarly, small y is nothing but capital X sin theta plus capital Y cos theta. So this is when you want to subject small x and small y. Similarly, if you want to subject capital X and capital Y, so capital X will be equal to small x cos theta. So this way you will be going plus small y sin theta. Okay. Similarly, capital Y will be equal to minus x sin theta plus y cos theta. So it depends whether you want to use small x, small y or capital X, capital Y. Based on that, you will be subjecting it. Okay. So let's discuss the solution. So in order to write down the solution, every time I want you to draw the table so that you won't get confused while proceeding with the solution, right? When the axes are rotated through an angle pi by 4, find the transformed equation of, so can you tell me whether this equation, is it the new equation or the old equation? Based on the text in the question, can you tell me whether it is the new equation or the old equation? All of you. Everyone should answer. More answers. Very good. Very good. More answers. Right? Clearly, the original equation. Wonderful. Right? So, let me write that statement. The original equation is, you can also use the term old equation, original equation, both of them are the same. The original equation is 3x square plus 10xy plus 3y square is equal to 9. So, are these capital X, capital Y or small x, small y only? Everyone? Because it is the original equation. Our denotion is that we use small x, small y for original equations and we use capital X, capital Y for new equations. So clearly it is the original equation, so it is small x, small y only. And we have to convert that into capital X and capital Y. So if this is the first one, right? If this is the first set and this is the second set, can you tell me which set of formulae should we be using to solve this problem? Should we use the first set or the second set? All of you. Yes, I should be using the first set to solve the problem because clearly I need to bring in capital X and capital Y and I already have small x and small y. Okay, so that will give me, so I'll just rewrite these equations again because the solution actually started here. So I'll rewrite these equations again. Cos theta minus y sin theta, which gives me small x is equal to capital X cos pi by 4 minus capital Y sin pi by 4. Okay, which in turn is equal to capital X into 1 by root 2. All right, 1 by root 2 minus capital Y into 1 by root 2 again. Okay, which you can of course write it as this. Similarly, small y is capital X sin theta plus capital Y cos theta, which is nothing but capital X into sin pi by 4 minus capital Y into cos pi by 4. Okay, right? That will give you x, in fact this is plus, so x plus y by root 2. That's it. Okay, the rest is quite simple. All you need to do is to replace these values here in place of small x and small y. That will give you, therefore, the new equation or the transformed equation is 3 into, right, capital X minus y by root 2 whole square plus 10 into capital X minus y by root 2 into capital X plus y by root 2. Okay, capital X plus y by root 2 plus 3 times capital X plus y by root 2 whole square is equal to 9. So simple algebra from here. Okay, so 3 root 2 whole square will be by 2. So expanding inside the bracket, I would be getting this minus 2xy plus root 2 into root 2 will be 2, I mean 2 goes in 10 5 times. So 5 into, right, x minus y into x plus y is nothing but x square minus y square, everything in capitals, plus the same logic, root 2 whole square is 2, 3 by 2 times x square plus y square plus 2xy is equal to 9. Okay. Now, 3 by 2x square plus 3 by 2x square is nothing but 3x square. Okay. 3 by 2x square plus 3x square is nothing but 3x square. Similarly, 3 by 2y square plus 3 by 2y square is nothing but 3y square. Okay. Then, so here you have 3 by 2 into 2xy. Okay. That will be minus 3xy plus 5 into x square minus y square plus the leftover terms. So these two I've already added here. So leftover is 3 by 2 into plus 2xy, which is nothing but plus 3xy is equal to 9, right? So this term gets cancelled and you are left with 3x square plus 5x square is nothing but 8x square plus 3y square minus 5y square is nothing but minus 2y square is equal to 9 is your final solution. That's your transformed equation. Is that clear, all of you? So let's move on to the next question, which will also be based on rotations. When the axes are rotated through an angle pi by 6, mind you, by the way, whenever the rotation happens in the counterclock, whenever you're given an angle in terms of rotation, the rotation actually happens in the counterclockwise direction, right? Find the transformed equation of so and so. Transformed equation or new equation, both of them mean the same. Isn't it the similar problem as we've done just now? Yes. So can you tell me? So the challenge lies in identifying whether this is the original equation or the new equation. Can you tell me whether this is the original equation or the transformed equation? Everyone? Very good. Very good. More answers? Is it the transformed equation or the original equation? So clearly given that you have to find the transformed equation of something, which means the transformed equation is yet to be found out and you're only given the original equation. Okay, so let's start with the solution directly. The original equation is x square plus 2 root 3 xy, right, minus y square is equal to 2a square. So basically we're going to deal with the roots here. So reason you already started with the root 3, and of course whenever you see a pi by 6, sine and cos, of course just cos will end up in square roots, but anyway that shouldn't affect the problem. So you know the table here already, right? So this table you need to be drawing each time and you'll apply whichever is suitable over here. Okay, so what's the table? Right, small x, small y, capital X, capital Y, cos theta minus sine theta, and then cos theta. Okay, since original equation is given, I should be writing a set of formulae, okay, which will convert small x into capital X. So naturally, I will be using these, right? Small x will be equal to capital X cos theta minus capital Y sin theta. Similarly, small y will be equal to capital X sin theta minus, in fact, plus capital Y cos theta, right? Since theta is equal to pi by 6, small x will be equal to x cos pi by 6. Keep writing down the steps. I'm sure all of you can write these things directly, but I strongly suggest you to write down the steps without skipping anything, right? Capital X cos pi by 6, capital Y sin pi by 6, okay, which is in turn equal to capital X root 3 by 2 minus capital Y by 2, which I'll write it as 1 by 2 times root 3x minus y. Yeah, just a little rearrangement of the terms. And then, of course, small y will be nothing but capital X sin theta, or directly I'll write it down, capital X sin pi by 6 plus capital Y cos pi by 6, which is nothing but capital X into 1 by 2 plus capital Y into root 3 by 2, which can be written as 1 by 2 into x plus root 3y. Okay, so now that I have these values, it's quite simple for me to substitute them over here. Okay, of course, a is a constant, it has no role to play, so just leave it like that. Let's substitute the other values that we've got in the original equation. Therefore, the transformed equation is, therefore, the transformed equation is, right? So x square can be written as half into root 3x minus y whole square minus 2 root 3 into xy. So x is root 3x minus y divided by 2 into y is x plus root 3y divided by 2, okay, plus y square. So square for this as well, okay, plus y square is nothing but half whole square into x plus root 3y whole square is equal to 2a square. This is anyway constant, has no role to play. So let's quickly expand this equation. So that's 1 by 4 of, I'm taking out this 1 by 4 common from all the terms. Okay. So root 3x minus y whole square is nothing but 3x square plus y square minus 2 root 3 xy, okay, minus 2 root 3 into, first let me expand this, root 3x square plus 3xy minus xy, okay, minus root 3y square. So these are the terms corresponding to this particular expansion, plus, and then of course I'll expand this, which is x square plus y, in fact 3y square plus 2 root 3 xy is equal to 2a square. In the next step, I'm going to multiply this 4 to the RHS and make it 8a square. Okay, so let's see what terms get cancelled. 2 root 3 xy gets cancelled. Okay, and what am I left with? That's 1 by 4 of 3x square. Okay, so in fact, I've multiplied by 4 to the RHS. Let me write one more step so that I can expand this bracket as well. It will be easier for you. So that will be 3x square plus 4 plus y square minus 2 root 3. I'm sending it inside. So that will be minus 2 into root 3 into root 3 into x square. That's minus 6x square. Okay, plus 2 root 3, right, into 3xy. So this is already simplified to 2xy. Okay, so that will be 2xy. Just give me a second. Right, so minus 2 root 3 into 2xy is minus 4 root 3 xy, and then plus 6y square plus of course x square plus y square is equal to 8a square. Okay, that 4 have cross multiplied, which is giving me 8a square. Any doubts, anyone? Right, So now I can easily simplify the terms to get 3x square minus 6x square plus x square is nothing but minus 2x square. Okay, y square plus 6y square plus y square is nothing but plus 8y square minus 4 root 3 xy is equal to 8a square. You may want to rearrange it. In fact, 2 gets cancelled, and minus also can be taken out common. So x square minus 4y square, okay, plus 2 root 3 xy is equal to minus 4a square. Okay. Any doubts here? Anyone? Yes, this is 3y square. Okay, so that will give you 10y square here. Okay, and that will give you 5y square here. Right? So it's just, again, simple calculations that you need to be careful about. Any doubts, anyone? All of you are clear? So let's move on to the next problem. When the axes are rotated through an angle 45 degrees, the transformed equation of the curve is so and so. So clearly, as given in the question, this is the transformed equation, right? This is a transformed equation, so I should convert it into the new equation. So quite simple problem again. Solution: the transformed equation is 17x square. So basically, since it is already the transformed equation, since it's already the transformed equation, okay, you have to write it in terms of capital X and capital Y. Okay, so that will give you capital X square minus 16 capital X capital Y plus 17 capital Y square is equal to 225. Right? So same table again. Should be very clear with the table. So that will give you small x, small y, capital X, capital Y, right? Cos theta minus sin theta and cos theta. But here, since the equation is in terms of capital X and capital Y, you should be writing equations which are subjecting capital X and capital Y, which is x cos theta plus y sin theta here, and capital Y will be minus x sin theta plus y cos theta. Okay, since theta, so theta is given to be what in the question? Theta is given to be equal to 45 degrees. Okay, that's pi by 4. I'll replace that here, which will give you x is equal to x cos 45 degrees plus y sine 45 degrees, which is nothing but x plus y by root 2. Something similar to what we have done previously. Y will be equal to minus x sine 45 degrees plus y, right? This is a small x, small y plus y cos 45 degrees. Okay, so that's equal to minus x plus y by root 2. Okay, all these are small x, small y. So let me just rewrite it without confusion. So x plus y by root 2. Okay, so therefore the original equation is, right, 17 into, okay, 17x square is the first term. Let me just confirm. Yeah, 17x square minus 16xy plus 17y square. So 17 into x square is nothing but x plus y by root 2 whole square minus 16 into xy, that is x plus y by root 2 into y minus x by root 2 plus 17 y square. It is nothing but y minus x by root 2 whole square is equal to 225. Okay, from here all you need to do is to expand it. That's 17, okay, into x square plus y square plus 2xy minus 16 into y square minus x square plus 17 into x square plus y square minus 2xy. So here there is a root 2 whole square, that will give you a 2. Here there is a root 2 into root 2, that's also a 2. Here there is a root 2 whole square, that's also a 2, which I will cross multiply and write in the RHS as 415. Okay. Then, so just expanding the terms, I would be getting 17x square plus 17y square plus 34xy minus 16y square plus 16x square plus 17x square plus 17y square minus 34xy is equal to 450. So 34xy gets cancelled with a 34xy here, right? Let's check the terms that are left over. 17x square plus 16x square plus 17x square is nothing but 50x square. Then 17y square minus 16y square, okay, plus 17y square. Clear? So that is plus 18y square is equal to 415. So you can observe that 2 comes out common, which will give you 25x square plus 9y square is equal to 225. You can leave the problem here, or you can also cross multiply and write it as x square by 9 plus y square by 25 is equal to 1. I've just cross multiplied this 225 onto the LHS. You can either leave the problem over here or you can proceed to write like this. Is it clear, all of you? Let's move on to the next problem. It's quite an easy one. Can you give this an attempt? When the axes are rotated through an angle alpha, find the transformed equation of x cos alpha plus y sin alpha is equal to p. Right? Just give it an attempt before I solve it. I'll give you 4 to 5 minutes. Try getting to the solution here. I'll wait for you. So let me solve this for you. Again, find the transformed equation of so and so. So let me draw the table. Small x, small y, capital X, capital Y, cos theta, sin theta, minus sin theta, cos theta. So this is the original equation. So I'll have to subject small x and small y. So that is small x, right, is equal to cos x, capital X cos theta minus capital Y sin theta. So clearly the angle is alpha. So that will give you small x will be equal to, right, small x will be equal to capital X cos alpha minus capital Y sin alpha. Similarly, y will be equal to capital X sin theta plus capital Y cos theta, which gives me small y is equal to capital X sin alpha plus capital Y cos alpha. These things I'll have to replace over here. So the original equation is small x cos theta plus small y sin theta is equal to p, right? So it's a simple equation. So which on conversion gives me, so small x here, small x will be nothing but capital X cos alpha minus capital Y sin alpha into cos alpha. This is alpha, okay, as given in the question. It's basically alpha plus y is nothing but x sin alpha plus y cos alpha into sin alpha is equal to p, right? So I'll give you x cos square alpha minus y sin alpha cos alpha plus x sin alpha cos alpha, in fact sin square alpha, all right, plus y sin alpha cos alpha is equal to p. So this gets cancelled. You're left with x cos square alpha plus x sin square alpha, which is simply nothing but x, and that is equal to p. Okay, so that's your final equation. Quite a simple problem. Any doubts, anyone? So just have a look at the next question. show that the axes are to be rotated through an angle so and so. This angle is what we are supposed to find out. So as to remove the xy term from the equation ax square plus 2hxy plus by square is equal to 0. Right? Again, similar problem, it's just that a little different from what we have solved previously. So let's first write down the relation between small x, small y, capital X and capital Y as usual. So that's capital X, capital Y, cos theta, sin theta, minus sin theta, and then cos theta. Okay. So the original equation is ax square plus 2hxy plus by square. Okay. So in order to convert that into the transformed equation, I should be subjecting small x and small y. So small x is equal to capital X cos theta minus capital Y sin theta, and small y is equal to capital X sin theta plus capital Y cos theta. Okay, so these two I'll replace in this equation. Observe carefully. So a into capital X cos theta minus capital Y sin theta whole square plus 2h into capital X cos theta minus capital X cos theta minus capital Y sin theta into then y is nothing but capital X sin theta plus capital Y cos theta plus b into y square, that is capital X sin theta whole plus capital Y cos theta whole square. Okay. So the advantage here is that cos equal to 0, the advantage here is that we don't have to expand this entire term. Okay. So what is asked for, you're only asked to remove the xy term here. Okay. So in order to remove the xy term, all you need to do is to identify where all will you be getting an xy term, right? So therefore, the coefficient of xy term is, so where all would you be getting an xy term? So here, if you actually expand, you don't really have to expand, but you can visualize it. X square cos square theta, there is no x square term, xy term, plus y square sin square theta, there is no xy term. But in the next term, that is minus 2xy sin theta cos theta, there will be an xy term. So xy of, right? So it's actually minus 2xy sin theta cos theta into a. So can that be written as minus 2a sin theta cos theta? Okay. Any doubts, anyone? Plus, similarly here, where do you see an xy term? There is an x cos theta and a y cos theta, which will get multiplied with both of them, but it will get multiplied with each other to give you xy cos square theta and of course a 2h. So plus 2h xy cos square theta. Similarly, minus 2h, so that xy I have anyway taken it out common, so I'll not write it down here. Okay. 2h cos square theta minus again 2h. I'm so sorry. 2h into x cos theta, y cos theta already over, minus y sin theta plus x sin theta is nothing but xy sin square theta. Okay. Plus here I would be getting a b cos theta sin theta again. Okay. This is your xy term, which should be removed, which means you should equate that to 0. All of you got it? Right? So just, in fact, there'll be a 2 also. Just take a minute to understand if all of these terms are clear. Yes, let me repeat once again. xy term. So where all do you get an xy term? So when you expand this, you'll get x square cos square theta plus y square sin square theta minus 2xy sin theta cos theta into a. Right? So xy taken out common. So minus 2a sin theta cos theta is what I've written. Similarly, 2h x cos theta plus y cos theta is nothing but xy cos square theta. That xy is taken out common. So 2h cos square theta is left over here. All right. Any doubts? Similarly, the other terms should be made 0. So I'll just further simplify this. So a as it is minus as it is 2 sin theta cos theta is nothing but sin 2 theta plus 2h into cos square theta minus sin square theta in these two terms plus b into sin 2 theta is equal to 0. Right? So from these two terms, first and last terms, I can take out sin 2 theta common and I'm left with b minus a plus 2h into cos square theta minus sin square theta. From the multiple angles formula, you know that it is nothing but cos 2 theta is equal to 0. Right? So I'll just rearrange the terms and write it as 2h cos theta is equal to a minus b into sin 2 theta, because when I send this here, it becomes a minus of the entire term. So b minus a becomes a minus b. So I'll cross multiply this, right? 2h by a minus b is equal to tan 2 theta, or in other words, tan 2 theta will be equal to 2h by a minus b, and then 2 theta will be equal to tan inverse of 2h by a minus b, which means theta is equal to half tan inverse of 2h by a minus b. Clear? All of you? Yeah, this is cos 2 theta. Any doubts, anyone? Right? So this is only the first part of the problem, observe. All right, just a second. This is the first part of the problem because it happens only when a is not equal to b, right? And what if a is equal to b? Okay, so you can just continue by writing one more step. If a is equal to b, then theta is equal to half tan inverse of 2h by 0, which is nothing but half into, so tan inverse of undefined, isn't it? Something divided by 0 is undefined, so tan inverse of undefined is pi by 2, so that is equal to pi by 4. Okay, therefore, if a is not equal to b, then theta is equal to half tan inverse of 2h by a minus b. And if a is equal to b, then theta is equal to pi by 4. Are we clear? Any doubts? Good. Right. Then moving on to the next term. Find the point to which the origin is to be shifted in order to remove the first degree terms from the equation 4x square plus 9y square minus 8x plus 36y plus 4 equal to 0. The first degree terms are supposed to be removed. Let's see what those are. Yes, in this equation, observe the degrees of each terms, right? So this term has a degree 2. Similarly, this term has a degree 2. But this term has a degree 1 and this term has a degree 1, whereas 4 has a degree 0. So you have to remove the first degree terms, which means x term and the y term are to be removed. And in order to remove those terms, what is the point to which the origin has to be shifted? That's your question. Okay. Right now, solution, let the point to which the origin is to be shifted be h comma k. That's your point to which the origin is to be shifted. Okay. So now the given equation, is it the original equation or the transformed equation? Clearly it is the original equation. And then of course I know that small x will be equal to capital X plus h and small y will be equal to capital Y plus k, which I'm going to replace over here. That will give me 4 into capital X plus h whole square plus 9 into capital Y plus k whole square minus 8 into capital X plus h plus 36 into capital Y plus k plus 4 is equal to 0. Right? When I expand this, I would be getting 4 into x square plus h square plus 2xh plus 9 into y square plus k square plus 2yk minus 8x minus 8h plus 36y plus 36k plus 4 is equal to 0. Right? Very simple algebra. All right. I'll just expand these terms as well. That will give me 4x square plus 4h square plus 8xh plus 9y square plus 9k square plus 18yk minus 8x, okay, minus 8h plus 36y plus 36k plus 4 is equal to 0. I'll group all the like terms. I'll just rearrange them in our standard order. So x square terms first, so that is 4x square, plus y square terms next, that is 9y square, plus x terms next. Where all do you see an x? There is an x here and there is an x here. So x into 8h minus 8, right? X into 8h minus 8 plus, where all do we see a y term? So that's a y term. That's another y term. So that will be y into 18k plus 36 plus all the constant terms. So 4h square, similarly 9k square, 8h, 36k and 4. These are all the 9 terms, constant terms. So 4h square plus 9k square minus 8h plus 36k plus 4 is equal to 0. So what is asked for in the question? You have to remove the first degree terms, right? So this is the first degree term and this is another first degree term which you are supposed to remove, right? In order to remove the first degree terms, okay, in order to remove the first degree terms, 8h minus 8 should be 0 and 18k plus 36 should be 0. These two terms will be cancelled, okay, which means h is 1 and then similarly k is equal to minus 2. Therefore, the origin has to be shifted to h comma k, whose coordinates are given by 1 comma minus 2, okay, in order to remove the first degree terms, right? In order to remove the first degree terms. Very, very simple problem. Fine. So with these 7 problems, you can definitely score 8 out of 8 marks in transformation of axis. Similarly, the previous 8 problems, you can score 8 out of 8 marks in locus. So both combined together, around 15 problems, you can easily score 16 marks, right?